Imagine waking up in Pune, pouring yourself a cup of coffee, and just stepping into your office in Mumbai before that coffee even gets cold.
Right, which is what, like 150
Yes.
kilometers?
Exactly, but you're doing it in roughly 15 minutes.
Oh, wow. That's fast.
No traffic, no turbulence, just smooth, silent speed. So, welcome to the deep dive.
Glad to be here.
Usually, when we examine massive infrastructure projects, we're talking about pouring more concrete or like making incremental upgrades to systems that have been around for a century.
Yeah, the usual traditional rail or highway expansions.
Right. But today, we're stepping into a high-yield briefing on a topic that fundamentally rewrites the laws of physics for public transport. Our mission today is India's Hyperloop program.
It's a huge shift.
It really is. And I want to be clear right off the bat to you listening. We are not just doing a casual chat about some shiny sci-fi train. We're treating this as a current affairs war room discussion. We are looking at this strictly through the lens of strategic policy analysis.
And that's a vital distinction to make. If you're analyzing this from a governance or a strategic perspective, you really have to understand the massive shift this represents for the country.
Right.
We are watching India move from, merely demonstrating a capability to actively asserting strategic autonomy. They're developing deep dual-use technological power here.
Because, as we sit here in 2025, the narrative has completely changed, hasn't it?
Totally. India isn't just standing in line waiting to buy tomorrow's technology from the global market at a huge premium. India is actually building it from the ground up.
And by the end of this deep dive, you, the listener, will have a structured, ironclad mental framework to analyze these kinds of advanced mobility solutions.
Especially if you're prepping for an exam or writing a policy brief.
Exactly. So let's establish our baseline. We need to look at the facts and data, what we call the memory layer. Our anchor point today is the Indian Institute of Technology, Madras.
The IIT Madras Discovery Campus.
Right. At their campus, they haven't just published a nice theoretical paper. They have successfully built and tested India's first Hyperloop test track.
Which is huge.
Yeah, we're looking at a 410-meter physical track. It's a full-on national research and validation platform.
And for everyone listening, keep that 410-meter metric locked in your mental database. It's incredibly important.
Why that specific number?
Well, because it proves we have moved past the hype cycle. Remember when the Hyperloop concept first blew up globally around, 2013?
Oh, yeah, it was all sleek renders and big promises. Vaporware. Oh, man.
Exactly. But the 2025 reality in India is about the gritty engineering of physical subscale validation. And 410 meters isn't just a random number they picked out of a hat.
Okay.
Mathematically, it is the precise sort of Goldilocks distance required to successfully test the acceleration of a pod, validate the magnetic propulsion, and safely engage the braking systems.
Ah, so you can do all that without turning the internal instruments or future passengers into jelly.
Right, exactly. Any shorter, and it's basically a toy. Any longer, and it's a massive unnecessary capital sink before the core systems are even proven.
Makes sense. And the priority route they've identified for potential full-scale deployment down the line is that Mumbai-Pune corridor I mentioned earlier.
Which is the perfect test case for economic integration.
Yeah. But before we get to the route and the economics, let's unpack the technological anatomy. If you are going to debate this topic or write an answer on it, you need to know exactly how the machine actually works.
Absolutely.
There are 6 critical components, so let's just break them down for the listener's memory bank. First, you have the tube itself.
And it's not just a pipe, right? It's a sealed, low-pressure, near-vacuum environment.
Right. Second is the passenger or freight pods. And those require the structural integrity of a literal spacecraft.
Because of the vacuum. Yeah.
Exactly. Third is the levitation system, which uses magnetic or air-bearing technology to eliminate friction.
Fourth would be the compressor systems to manage any residual air.
Yep. Fifth is the propulsion system, specifically utilizing linear induction or synchronous motors. And finally, the 6th component is the advanced control and safety systems.
Let's give those components some life. Because just listing them is one thing, but understanding the how and the why is what really elevates your analysis.
Go for it.
Think of the 2 fundamental enemies of traditional high-speed transport. You have aerodynamic drag and mechanical friction.
Right. Air resistance and the wheels hitting the track.
Exactly. A bullet train loses massive amounts of energy just violently shoving the atmosphere out of its way and fighting the physical friction of steel wheels on steel tracks.
So the Hyperloop just bypasses both.
Yeah. By placing a highly engineered pressure vessel pod inside a near vacuum tube, you effectively delete the atmosphere. And by levitating it magnetically, you basically delete the ground.
Okay, I've always pictured those pneumatic tube systems you see at a bank drive-through.
Oh yeah, the plastic cylinders.
Right. You put your deposit slip in a cylinder, it goes into a pipe, and just whoosh, it gets sucked right into the teller's office. I imagine that. But on a massive human-sized scale.
I love that visual, actually, and it gets us halfway there, but let's tweak the physics just a bit to make it completely accurate for your analytical framework.
Okay, correct me.
So in that bank tube, a compressor is aggressively blowing air to shove the canister forward. Air is the fuel. But in a Hyperloop, air is the enemy.
Oh, I see.
Yeah, the compressors are actively sucking all the air out of the tube to create an environment that mimics low Earth orbit, almost zero resistance. And instead of air pushing the pod, magnets do the work.
Which brings us to the linear induction motor. And I gotta ask, explain that to me like I'm 5. Because linear induction sounds like something straight out of a sci-fi movie.
It sounds super complex, but it's surprisingly intuitive. Picture a standard electric motor, like the kind spinning the blades of a desk fan or the wheels of an RC car.
Okay, a spinning cylinder.
Right. It's a cylinder spinning in a circle, driven by electromagnets. Now imagine taking that circular motor, cutting it open, and just unrolling it perfectly flat along the ground.
Wait, really? Just laying it flat?
Yeah, that's a linear induction motor. Instead of the magnetic force spinning something in a circle, the magnetic force pushes the pod forward in a perfectly straight line down the track.
Wow, okay, so we have a frictionless pod in a near vacuum being propelled by an unrolled magnetic motor hitting theoretical speeds of over 1,000 kilometers per hour.
It's literally short-haul aviation on the ground.
It really is. So with the physical engineering mapped out, we have to pivot to the significance analysis. Like, why is the government pouring resources into this right now?
This is where you connect the themes for your exam answers.
Exactly. If you're building a strategic argument, you want to map it out like this. Technology transformation acts as the catalyst for economic integration, which then enables sustainable governance, which ultimately elevates India's global standing.
Let's dive deep into that second link, economic integration. Because what does a 15-minute commute between Mumbai and Pune actually mean?
It means I get home earlier.
Well, yes, but macroeconomically, when you compress geography that drastically, you fundamentally rewire the economy. You merge two distinct, massive urban clusters into a single, unified megacity.
Oh, wow. Housing markets integrate. Talent pools merge.
Exactly. A tech company in Mumbai can seamlessly hire a brilliant engineer living in Pune without asking them to relocate or suffer a grueling, 3-hour commute. It is practically teleportation for the labor force.
That completely changes the socioeconomic reality of a region.
Yeah.
And the second dimension here is logistics. We naturally think about passengers, but moving time-sensitive cargo could completely revolutionize supply chains.
Think about e-commerce or medical supplies.
Right. Imagine moving high-value electronics or critical organs across the entire country in 3 hours instead of 3 days. You completely bypass the congestion of national highways.
And don't forget the third massive benefit, energy efficiency.
Well, the solar aspect.
Yeah, you have hundreds of kilometers of structural tube just baking in the sun. The explicit design potential here is to line the entire top of the tube infrastructure with solar arrays.
So it's a transport system that doubles as a renewable power plant.
Ah.
That's incredible.
Yeah.
But look, I have to step in here and be the voice of the taxpayer, the realist.
Fair enough. Lay it on me.
We have to do a reality check.
Yeah.
India currently has massive traditional high-speed rail projects underway, like the Vande Bharat rollout and the Mumbai-Ahmedabad bullet train.
Right.
And our standard local rail networks are still incredibly overcrowded and need constant modernization. So I have to push back here. Is pouring billions of rupees into a near-vacuum levitating space train just an expensive distraction when we haven't perfected the basics?
That is the exact debate happening in policy circles right now, and it is a critical question to address. To answer it, you really have to understand the government's long-term rationale, specifically the Atmanirbhar Bharat, or Self-Reliant India mandate.
Okay, so it's about self-reliance.
Yes. This Hyperloop program is not an immediate commercial deployment aimed at fixing today's traffic jams. It is a research-led generational bet.
A long-term play.
Very long-term. If India waits for the United States or Europe to perfect a transformative technology, India will spend the next 50 years paying trillions of dollars to lease that intellectual property.
So We are spending the money now on the foundational R&D, so we actually own the patents later.
Exactly that. Furthermore, the technology is inherently dual use.
What do you mean by dual use in this context?
Well, the advanced material science, the near vacuum containment systems, the magnetic levitation mastering these technologies bleeds directly into advancements in aerospace, defense, and high-tech manufacturing.
Right, it's not just about trains.
No, you cannot achieve true strategic autonomy if you are perpetually just a consumer of advanced technology. You have to be the creator.
Fair point. But let's dig into the roadblocks, because honestly, they are severe. If you are analyzing this objectively, you have to balance those ambitious goals with the realistic structural limitations.
And there are many.
Yeah. We can group these challenges into three distinct administrative buckets. The first bucket is infrastructure. Let's talk about the sheer, staggering capital cost of constructing hundreds of kilometers of perfectly sealed steel tubes.
And the massive concrete pylons to support them, the capital intensity is just unmatched.
Right.
And beyond the money, there is the engineering reality. To maintain speeds of 1,000 kilometers per hour, the track has to be almost perfectly straight. You can't have sharp turns at the speed of sound.
Which makes land acquisition in a densely populated country like India an absolute logistical nightmare.
Exactly. Then you factor in varying terrain, the thermal expansion of hundreds of kilometers of steel baking in the Indian summer, and the most terrifying variable, seismic zones.
Right. If I'm driving my car and I hit a pothole, I spill my coffee. It's annoying. If a high-speed bullet train track gets slightly misaligned by a minor earthquake, it's a huge problem.
Yes.
But if a near-vacuum tube gets a microscopic, millimeter-wide structural crack from an
We
earthquake,
get a catastrophic atmospheric implosion.
good Lord.
Yeah, the outside air violently rushes into the vacuum at the speed of sound, creating a literal shock wave inside the tube. So the engineering tolerances aren't just tight, they have to be absolutely flawless.
Which brings us to the second bucket, regulatory and safety. This is where I see a truly fascinating paradox. There is an absolute absence of a dedicated regulatory framework for vacuum-based transport anywhere on the planet.
Yep, no one has written the rules yet.
Who writes the safety manual for a land submarine operating in a vacuum?
That regulatory void is what makes this such a high-yield analytical topic. Consider the safety certifications required just for a standard pressure vessel, let alone a moving one filled with people.
Right. How do you even design an evacuation protocol?
Exactly. If a pod loses power halfway between Pune and Mumbai, the environment outside the pod's door has literally no oxygen. You can't just open a window and walk along the tracks to safety.
You'd essentially need spacesuits. Or the tube itself would have to rapidly repressurize safely somehow.
Yes, and doing that safely is incredibly complex.
It emphasizes the reality that India doesn't just have to invent the technology. It has to pioneer the global legal and safety frameworks.
Which is a huge hurdle.
And the third bucket is technological and operational barriers. I mean, there is incredibly limited global operational experience with full-scale systems.
Practically none. We need years, maybe decades, of long-duration testing just to establish baseline reliability. You have to measure metal fatigue over thousands of pressurization cycles.
All of this brings us to the synthesis. We've mapped out the physical engineering, the strategic economic benefits, and these massive infrastructure and regulatory roadblocks.
So the question for you, the listener, is how do you convert this complex web of information into something highly actionable?
Right. If you are stepping into an exam hall, briefing a minister, or drafting a policy essay, how do you format this for maximum impact?
Let's do a quick mentorship session right now on structuring this information using the right administrative vocabulary.
Okay, let's say I'm in an elevator with a key decision maker, and I literally have 30 seconds. I need a tight 150-word equivalent pitch. Give me the framework.
All right. For the short, high-impact pitch, your introduction must immediately anchor the context. Cite the IIT Madras 410-meter track as the crucial milestone in advanced R&D and subscale validation.
Okay, start with the facts.
Then, you hit three body arguments rapidly. First, the drive for technological self-reliance. Second, the potential for deep economic integration between major urban clusters. And third, the immediate infrastructure and regulatory hurdles.
And then close it out.
Yeah, you wrap up with the way ahead, focusing strictly on the need to develop indigenous expertise and pioneer global safety standards.
That's great. It's concise and hits all the strategic notes. But what if I'm drafting a comprehensive 250-word equivalent policy memo or a long-form essay? I need a deeper analytical structure.
For the comprehensive memo, you expand your dimensions. Start with the current context. firmly state that as of 2025, we are in an advanced validation stage, not an imminent commercial deployment.
Manage expectations up front.
Right. Then, clearly outline the three dimensions of impact: the passenger speed revolution, the cargo logistics transformation, and the sustainable solar energy integration.
And for the challenges section of that deeper memo, I'd bring in those three buckets we discussed, right? The capital and seismic infrastructure risks, the regulatory void, and the technological testing barriers.
You've got it perfectly. And from there, you must provide concrete recommendations. This is where you use terms like institutional strengthening.
Oh, examiners love that phrase.
They really do. Bring up the necessity for public-private partnerships and industry collaboration to drive down costs. Emphasize the urgent need to pioneer new safety certification standards.
And what's the big finish?
Your conclusion should synthesize the overarching theme: that the Hyperloop program is less about an immediate fix for today's traffic and more about permanently positioning India at the forefront of advanced global transport research.
I want to highlight the specific keywords you should be consciously dropping into your arguments, whether written or spoken, to show you truly understand the landscape.
The analytical anchors.
Yes.
Oh.
Make sure you use the phrase indigenous subsystems. Use the term subscale validation. That proves you know we are in the testing phase, not the deployment phase.
And definitely talk about the regulatory framework and technological self-reliance.
Bringing those themes together is what separates a surface-level observation from senior-level strategic analysis. When you discuss the Hyperloop, you shouldn't just be discussing a train.
No, you're discussing a convergence point.
Exactly. It is the intersection of digital India, climate resilience through solar infrastructure, and ultimate strategic autonomy. It's the recurring governance pattern of a nation moving from merely demonstrating a capability to wielding deep technological power.
It's a textbook example of that shift.
All right, we are heading into the final revision capsule. Let's lock this entire briefing into your memory layer. We are going to do a rapid-fire, 30-second last-minute summary. If you take nothing else away from this deep dive, here are your 5 must-remember facts. 1. The physical reality is the 410-meter test track at the IIT Madras Discovery Campus.
2. The priority route for the future is the Mumbai-Pune Economic Corridor.
3. We are looking at theoretical speeds exceeding 1,000 kilometers per hour.
4. The mechanics rely on a low-pressure tube combined with magnetic levitation.
And 5. The 2025 reality is strictly focused on advanced research and indigenous subsystems, not imminent commercial deployment.
Perfect. And here is the core analytical question you should be preparing for if you're facing an interview board or writing a major paper.
Let's hear it.
Critically evaluate the technological and regulatory feasibility of integrating Hyperloop systems into an existing public transport infrastructure.
That's a solid prompt. And to answer that beautifully, here are your 5 analytical keywords to deploy. Strategic autonomy, regulatory void, subscale validation, linear induction propulsion, atmanira farvarat.
If you build your analysis using those components, thoughtfully balancing the transformative potential of unified megacities against the harsh, unforgiving realities of capital constraints and near-vacuum safety physics.
You demonstrate a masterful grasp of modern strategic policy.
Exactly. You see the whole board.
We're going to leave you with one final overarching thought to mull over. We spent some time talking about the regulatory paradox earlier.
The fact that there are literally no laws for this specific type of transport yet.
Right. The challenges are monumental, yes. But think about the leverage. If India is the first nation to truly split the safety equations and draft the first viable regulatory framework for a near-vacuum transport system.
They're just building a faster train.
Exactly. They are writing the literal global rulebook that the rest of the world will eventually have to buy into. Thanks for joining us in the deep dive. We'll catch you next time.